a sine theta, y varies according to the sine of angle theta. Now, y equal to a sine theta, we have now expressed y, the displacement of oscillation, as a function of the angle theta. But we want to express y as a function of time. How will we do that? Well, do you remember the concept we discussed in Physics 1? The angular velocity. When an object is revolving around a circle, what is the definition of angular velocity? You see, as this object goes round, the angle theta is increasing steadily. And what is the rate at which the angle increases? The rate at which angle is being described is called angular velocity. We represent that by the Greek letter omega. Is that right? I hope you remember. Omega is the rate at which the angle is being described. Omega equal to theta over t. What is the unit of omega, the angular velocity? Angle is measured in radian and the time is in second. Therefore, omega, the angular velocity, is measured in radian per second. Now, don't get carried away when I have marked the angles in degrees here, but when you represent these quantities, these mathematical equations, do not use angle in degrees. They use angle in radians. So, angle should be always represented in radians. Now, solving this equation for theta gives me theta equal to, can you solve it? Theta equal to omega times t. So theta equal to omega t. Well, what all we need to do is, in the equation for y, replace theta by this quantity. And what is the equation for the displacement y? We have y equal to a sine omega t. Now look at this. We have now obtained an equation for the displacement of the oscillation as a function of time. Y equal to a sine omega t, where omega is the angular velocity, or sometimes it's called the angular frequency. Omega is the angular frequency of oscillation. Well, when omega is a constant, y depends only on time. Now, in normal oscillations, omega will be a constant. In other words, the rate at which the angle is being described remains a constant. That means when omega is a constant, y, the displacement of oscillation, depends only on this time t. So we have y is now expressed as a function of time. Y equal to a sine omega t. Now, the vertical oscillations of a load attached to a spring is similar to the vertical oscillation of the projection. You see, the oscillations of the projection O is exactly the same as the oscillations of the loaded spring. Therefore, we can take that equation and use it for the loaded spring. The displacement of the oscillating object is given by, therefore, y equal to a sine omega t. Now, can you draw a graph of that, a sine graph? The displacement is given by a sine omega t, and the graph therefore will be at t equal to 0, the object is at the origin, and as t increases, the displacement increases to a maximum, it decreases to 0, it decreases to a negative minimum, increases to 0, that is one full cycle. And the graph of the displacement will be a sine graph. So this graph represents the variation of the displacement. You can see from 0 to pi by 2, the displacement increases and reaches the maximum. From pi by 2 to pi, the displacement decreases to 0. From pi to 3 pi by 2, displacement decreases to a negative minimum. From 3 pi by 2 to 2 pi, the displacement is back to 0. So this represents the displacement of the oscillating object for one full cycle. Now, what is one full cycle here? If you look at the object here, one full cycle is, this is the equilibrium position. It goes up, maximum displacement, comes back to displacement 0, goes to the lower extreme, displacement is a minimum, comes back to the equilibrium position. This is one full oscillation, and during that one full oscillation, the change in the displacement is given by this sine function, y equal to a sine omega t. Here A is the amplitude of the oscillation, isn't it? A is the maximum displacement. Now, this is a measure of the amplitude. That is the maximum displacement. So, that is the amplitude of oscillation, which is the radius of the circle. Now, here we assume that when t equal to 0, the oscillating object is at the equilibrium position. Now, this equation is true only if the oscillating object is at the origin, at the equilibrium position, when you start your clock, and it begins to go up, then back, and so on. On the other hand, if the object is at any other position when you start the clock, then this equation needs to be modified. Alright, that means this equation corresponds to theta equal to 0 when t equal to 0. Is that right? When t equal to 0, theta equal to 0 means the object is at the equilibrium position. Now, on the other hand, at t equal to 0, if the object is at B, that is here, alright, that means at t equal to 0, we have already covered an angle pi by 2. When you start your clock, if you start your clock when the object reaches the upper extreme, that means the angle is no longer 0, the angle now is pi by 2. So, if at t equal to 0, the object is at B, this corresponds to an angular displacement theta equal to pi by 2. Therefore, the equation of the displacement needs to take that into account. Now, how will the equation change? The equation will now become y equal to a sine omega t plus pi by 2, because the angle has now become pi by 2 when you start the clock. So your equation now has to be modified, y equal to a sine omega t plus pi by 2. Now, can you use your trigonometry to expand that? If you expand that, you will see this is equal to a cos omega t. Do you know how to expand that? Well, let me see. How many of you know? I know many of you don't. How many of you know the expansion of sine A plus B? That will be sine A cos B plus cos A sine B. Have you heard of that equation in trigonometry? sine of, well, let's get away with that a. We need only sine. I don't want that a there. But let's cut that a off. Sine of a plus b equal to sine a cos b plus cos a sine b. In this case, our a is omega t and our b is pi by 2. So, if I replace a by omega t and b by pi by 2, let's see what that will bring us. That will be sine of omega t plus pi by 2 equal to sine of omega t cos of pi by 2 plus cos omega t sine pi by 2. Now what all I did is replace a by omega t and b by pi by 2 to get this. Alright, tell me, what is the value of cos pi by 2? I want to know how many of you know that. Cos pi by 2, cos of 90 degrees is 0. So cos pi by 2 is 0, which means that term will disappear. This will go because cos pi by 2 is 0. And what is the value of sine pi by 2? Those are basic things in trigonometry. Sine pi by 2 is 1. So this quantity will reduce to cos omega t times 1. Look at this. Sine omega t plus pi by 2 is cos omega t. That's what this equation is. Okay. Well, at least some of you knew that. Is that right? So, if when you started the clock, the object is at B, then the equation becomes y equal to a cos omega t. It is a cosine graph. Look at the graph of the cosine function. The displacement is maximum at t equal to 0. Displacement is 0, reduces to a minimum and increases to a maximum. The angle pi by 2 is called the phase angle of the oscillation. What is the meaning of phase? P-H-A-S-E. Phase tells you where exactly is the object when you start your clock. You see, if theta equal to pi by 2, it tells you directly that when you start the clock, the object is at B. Well, let me ask you this. Suppose the object is at the origin and instead of moving up, it is now going to move down. What is the phase angle at that time? If the object is at the origin and it is beginning to move down, it means it has gone up and come back. That means the angle has now become pi. The phase angle at that time is pi. What happens when you start the clock? The object is at the lower extreme. What is the phase angle then? The phase angle will be 3 pi by 2. That's right. So here the angle pi by 2 in this case when the object is at B is pi by 2. The phase angle tells you exactly where the object is when you start your clock. Now we will represent the phase angle by the letter delta. If delta represents the phase angle, then the equation for the displacement, we can now replace this pi by 2 by this delta. So what is the general equation of displacement? The general equation is y equal to a sine omega t plus delta. This delta, the value of that delta will tell you where exactly the object is when you start the clock. If delta equal to 0,